In this video, we are going to discuss example 5.3. The problem says a spring has a length of 15.4 centimeter and is hanging vertically from a support point above it as shown in the figure. A weight of mass 0.200 kilogram is attached to the spring, causing it to extend to a length of 28.6 centimeter. First part of the problem wants me to find what is the value of the spring constant, and the second part says how much force is needed to hold the weight at a position 4.6 centimeter above negative 28.6 centimeter. So let us discuss what the question has given us. If you look at the figure, you will notice that this has been given as the equilibrium point where they have written 0. Below the equilibrium point, all my values will be negative. So length of the spring is negative 15.4 centimeter. And when you attach a mass to the spring, it is stretched to a point of negative 28.6 centimeter. So let us write down, let this be the position of my spring, the new equilibrium position, which is negative 15.4. I will call this x0. And the position at which the mass has stretched the spring, 28.6, I will call this as x. Let us write the given quantities. I will write x0 as negative 15.4 centimeter. Negative because it is below the initial equilibrium position. I will convert this to meter by dividing it by 100. That will give me negative 0.154 meter. The spring is stretched to a position of negative 28.6 when you attach the mass. And when I convert this to meter, I get negative 0.286 meter. The mass of the object is 0.200 kilogram. I need to find in the first part of the question what is the spring constant. So I'm going to use the relationship between force, spring constant, and displacement. We know the spring force from Hooke's law is given as negative k times delta x, which you can write as negative k times position x1 minus the equilibrium position. I don't have the spring force, but we know that this force has to be equal to the weight of the object. And weight of the object can be written as m into g. So I will replace my restoring force of the spring with the weight of the object, which is m into g, equals negative k x1 minus x0. Let's rearrange the term to solve for k. I will divide with x1 minus x0 here. So we can write k equals mg over negative x1 minus x0. Let's substitute the value. Mass of the object is 0.2. G is 9.81 over negative. X1 is negative 0.286 minus negative 0.154. And when you solve this, you get your K as 14.386 Newton per meter. So this is how you calculate your spring constant using Hooke's law. If an object is hanging from the spring and they have not given you the restoring force, you can equate the restoring force to the weight of the object, which is given as m into g. So this was problem 1. Part 2 of the problem is asking me how much force is needed to hold the weight at a position 4.6 centimeter above negative 28.6 centimeter. So I need to find how much force is needed to hold my weight from this position to this position over here. So let negative 28.6 be my new equilibrium position, negative 28.6. And my displacement from the equilibrium position is 4.6 centimeter, which I can write as 0.046 meter. I need to find how much force is needed to hold the weight at this position. The force that I need to hold the object at this position here, it must be equal to the negative of the spring force. So the force we apply must be negative of the spring force. And we know spring force from Hooke's law is given as negative K times delta X, which will be equal to negative times negative will give you positive K delta X. Now let's substitute K we found in the previous part of the problem, 14.86. Delta X is 0.046 meter. And when you solve these two together, you get your force as 0.68 Newton. So this is the force I must apply on the weight to hold this at a position of negative 24.0